Then we move on to train and split and model training. So we import logistic regression from sklearn linear model, import a random classifier from n assemble, import a test train.test split from model and selection, import accuracy score, precision score, recall, and F1 score from metrics. So models is equal to logistic regression with its parameters and random forest with its parameters. Basically, this defines the models that we're going to be using, and then we have results is equal to empty brackets. Basically, this stores the results. Then we move on to print training, land models with land scalar methods. For a scalar name, scalar and scalar items, print scalar name. Basically, what this trains the models with different scaling methods. Then we have if scalar is equal to none, x scaled is equal to x, or else is x scaled is equal to pd.dataframe scalar.fit transform columns x columns index is x.index. Basically, this allows us to apply scaling. Then we will have x train x test, y train y test, which is equal to train test split with its parameters. Basically, just train and test the data set as 80% goes into training and 20% goes into testing. Then we have for model name, module, and model item. Basically, it loops through the model items and basically trains the model with model.fit with x train and y train, and with y predict equal model predict x train. Then we move on to accuracy all the way to f1. Basically, this evaluates the model in terms of these categories from accuracy, precision, recall, and f1 score. And then we move on to results append, which has scaling all the way down to f1 score. Basically, this stores the results for like the models. Then afterwards, we basically print out the model with its accuracy and f1 score. Here we have the output. So our original scaling with logistic has an accuracy of 0.905 and a F1 score 0.904, random forest accuracy of 0.996 and F1 of 0.996. Standard scalar scaling, logistic regression, all the way till robust scalar scaling with logistic regression accuracy of 0.920 and F1 of 0.920, and finally with random forest with accuracy of 0.996 and an F1 score of 0.996. Then we move on to printing out the result summary. So result df is equal to pd.dataframe is equal to the results. Then we print out results df is equal to round 4. Basically, this rounds all the numerical values in the results data frame to like the fourth decimal place. So here's the overall model performance summary for each. So here we have the original for a logistic regression and random forest, all the way to robust scalar for logistic regression and random forest. Then we move on to finding the best performing model overall by using best index is equal to result dff1 score.id max and best results equal to results.df.log best idx, and this prints out the model scaling method f1 score accuracy precision recall. So the best performing model overall is a model a random forest with the scaling method original, which has a high F1 score of 0.9965, accuracy of 0.9965, precision of 0.9965, and recall of 0.9665. Then we move on to feature importance analysis. So this allows us to see what features were important. So best scalar is equal to scalars best results scaling all the way to x final pd.dataframe best scalar is fit transform x columns equal to x on column. Basically, this uses the best scaling method for like the feature analysis. Then we move on to rf.model is equal to random forest classifier with these parameters all the way to rf.model.fit x final and y. Basically, this trains the random forest model for like the feature importance. Then we move on to importance. df is equal to pd.dataframe with feature importance, and where we sort the values by importance, ascending and equal to false. Basically, this creates like a feature importance data frames and sorts them by like the importance. Afterwards, we move on to visualizing the top 10 most important feature. So here we create a bar plot with the data importance data frame head, and then with x importance and y feature, that was labeled the title, the x value, and then we plot it over here. So here's the visualization. So the top 10 most important feature for the random forest classifier is the achievable score with a feature importance about 0.6 all the way down to total assets, which has the lowest around like 0.0, almost close to 0.0. And here, like the top 10 most important features as supported by the graph here, which is like the feature of Chibble score of point importance of like 0.635467, and all the way down to like total assets, which has an importance score of like 0.009160. So yeah. So this was the overall project. So thank you for watching and listening.